All right, so now we get into one of our big important concepts that we're going to see through most of the rest of the course, to be honest. So we want to look at our new vocabulary word, and it seems kind of silly to say that weight is a vocabulary word, but it does have special meaning and even a formula that goes with it, so we'll want to pay attention. All right, so weight, as it turns out, is the special combination of mass and gravity for an object. Mass is basically the atoms and molecules that make up something. It's the total amount of matter that make up the object. Then gravity is a number we've talked about before. On Earth at roughly sea level, which is the assumption we'll make unless we have other information, we have that gravity is 9.8 meters per second squared. Now, one of the issues that we have when we cover these topics is that a lot of times students are used to hearing these words used in a slightly incorrect context. You need to recognize always and forever that kilograms are a measure of mass. And if you learn that, put it on a flashcard, write it down, highlight it, something, you're going to have a much better time. We cannot mix and match these things. Kilograms are mass. Unfortunately, in regular conversation, sometimes people will say that something weighs a certain number of kilograms, and technically that's impossible because kilograms are a measure of mass. They just do different things. When we put those together, mass and gravity, then we can get weight, and weight is a special type of force, so it's measured in newtons. Probably guess who that's named after, but we'll talk about that more later. All right, so here, we don't know the weight of the object. We do know the mass from the question is 32.71 kilograms. We are expected to be able to come up with gravity either from a formula sheet or from memory or from maybe another question if it's a weird set of connected questions. Here we're assuming we're on Earth and we've got our magic number. Now here's where something a little bit unfortunate happens. Newton got to put his name on this because he was, one of the first people working on all of this. But the N stands for a bunch of other stuff. So it's what's called the derived unit. And that means that it comes from a combination of other units. In particular, we need to remember that the capital N for Newton is the combination of kilograms and meters per second squared put together. Okay, so from that, we can finally get an answer here. We have that weird definition. You need to remember that kilograms and meters per second squared get combined to make newtons, and then multiplying these two together in a calculator, 320.56.